Bismillahirrahmanirrahim. On the demand of living waters from Zimbabwe. This problem is related to probability. Problem is machines A and B produce 10% and 90% respectively of the production of a component intended for the motor industry. From experience, it is known that the probability that machine A produces a defective component is 0.01, while the probability that the machine B produces a defective component is 0.05. If a component is selected at random from a day production and is found to be defective, find the probability that it was made by machine A and machine B. There is two problems associated with this common problem. This problem is related to Bayes theorem. So I apply here Bayes theorem after defining some events. So I define events and write here, let E1, E2 and E be the events defined as follows. E1, the E1 event is defined as E1 is equal to the component is manufactured by machine A. E2, the component is manufactured by machine B. Now I define another event. E is equal to the component is defective. Then we can say probability of event E1 is equal to P1 is equal to probability that the component selected is manufactured by machine A is equal to, means so P1 is equal to, which is given here, machine A and B produce 10% and 90% respectively of the production of the component intended for the motor industry. So we find P1 here. This given value is in percentage. We convert it into probability because we find here Pe1. So we write 10% as 10/100, which is probability notation representation of 10% production for machine A, from total production of motor industry. Now similarly we will find PE2. Here PE1 is defined as probability that a component selected is manufactured by machine A. Similarly we write here probability that the component selected is manufactured by machine B is equal to, which is given here, which is 90%, 10% for machine A and B% for machine, so 90% for machine B, which is given production related to machine A and B, but here this value is given in percentage, but we find here probability of E2. E2 is defined, the component is manufactured by machine B, so we can find the probability of PE2, which is also defined here. PE2 is equal to probability that the component selected is manufactured by machine B. E2 also defined here, the component is manufactured by machine B. So we write here 90/100. Now we define another probability, which is conditional probability PE/E1, which means that probability that the component selected is defective given that is manufactured by machine A, which is given here. From experience, it is known that the probability that machine A produce a defective component is 0.01, which means this event, and that probability is PE/E1, which is called conditional probability and defined as probability that the component selected is defective given that it is manufactured by machine A, which is given in question 0.01. Similarly, we can find PE/E2. These probabilities will use in Bayes theorem. So we find here and write here previously. PE/E2 is probability that language is same, probability that the component selected is defective given that is manufactured by machine B, which is given here 0.05. which is given in question, that the while the probability that the machine B produce a defective component is 0.05. So I write value of PE by E2 is equal to 0.05, which is equal to PE by E2. Now we have to find if a component is selected at random from a day's production and is found to be defective, find the probability that it was made by machine A and machine B. Here two questions for us, so we solve one by one. First we solve A part and then B part by applying the Bayes theorem. So we start question A, in which required probability is equal to, here required probability is probability that the component is manufactured by machine A given that component selected is defective. We have to find P E1 by E. We will find it by use of Bayes theorem. Bayes theorem formula for this value is, I write next page, which is equal to the required probability is equal to, by Bayes theorem we write PE1 into P E by E1 and PE1 into P E by E1 plus PE2 into P E by E2. You are see that these values are equal. Now I will put the respective probability of these. The value of PE1 is 10 upon 100. Also this value is, we write on previous page is 0.01. so this value is same, so I write this value here, 10 upon 100 into 0.01 plus now we write the value of PE2, which is equal to 90 upon 100. We have written in the previous page, and PE upon E2 is 0.05. Now we have to calculate this value. Here we see that 100 is common, both numerator and denominator, so take out 1 upon 100 from numerator. The remaining value 10 and 0.01 multiplied multiplication of this value is equal to 0.1. Also if we take 1 upon 100 common, so we get this value is same, 0.1. Also we multiply 90 to 0.05, we get 4.5. Cancel out 1 upon 100 from numerator and denominator, we get 0.1 upon, on adding this we get 4.6. Now this point we can terminate this point here and here, we get 1 upon 46. This is required probability for section A. For section B, we start second part. For machine B, this value is common for machine A and B, and other values is also common. So we separate this question from here, both part here, and now we solve second part. In this case, required probability is equal to probability that the component is manufactured by machine B, given that the component selected is defective, which is required probability, means P E2 by E. By Bayes theorem, we write for this value P E2 multiplied by P E by E2. This value is same in this part, P E2 into P E by E2. Denominator is same in previous question and this question. So we write PE1 into PE by E1. This value is common in both the cases. For A, here we write E1, and for B we write here E2. E1 E2 is defined also, you can see again, and I will put the value of PE2, which is equal to 90 upon 100, and PE upon E2 is equal to 0.05. This value we write from previous section. So we write this value, and also this is same. So I write by seeing this. Now same calculation, we take out 1 upon 100 from numerator and denominator, we get 0.05 in numerator, and also 1 upon 100 common in two terms, we get in first term 0.1, and in second term 4.5. because 1 upon 100 is taken out, we multiply 10 to 0.5 and 92.05, we get this value. Cancel out 1 upon 100 in numerator and denominator, we get 0.05. Here 90 is multiplied to 0.05, so we get 4.5. Here is mistake done by me, so you write this value, because this value is equal to this, so this value is equal to this. I write here 4.5 upon, on adding this value we get 4.6. Terminate point from here, numerator denominator, we can write 45 upon 46, which is the required probability for case second for machine B. Thank you very much indeed for listening me. Wa akhiru da'wana alhamdulillahi rabbil alamin.